Hello, everyone from virtual Belfast, and welcome to Belfast Gophers Meetup. Hopefully, you'll find the next hour or so informative and helpful for you. Just a very quick intro. So, my name is Martin Gallagher, and I'll be your host this evening. It's my first time emceeing a meetup, so please be gentle. Although, as some of you may already be aware, I'm a recruiter, and I've been in recruitment for over 20 years. So basically, I'm now like a soulless shell of a human being, and I'm immune to any criticism or judgment from the human race. So do your best. Now, in terms of a few announcements to start with, obviously we have to thank our sponsors. So these are the sponsors of tonight's meetup. We got obviously Cloud Shuttle and Teamwork and JetBrains and myself at Vistas Recruitment. So it's always nice to be able to thank yourself every now and again. In terms of Teamwork, one of the sponsors wanted us to mention they have a live event happening on the 22nd of October at 8 p.m. UK time, so 3 p.m. Eastern time in the States. And it's basically an event discussing basically remote working and how people and technology can come together now to help push growth in the current climate. So the CEO of Teamwork will be talking on with the CEO of Hive Tech HR. It's free to sign up. You can follow the link there on the slide. I think maybe Alan will put the link in the chat as well if you want to. So that's on the 22nd of October at 3 p.m. EST or 8 p.m. UK time. Now, not only have we got Matt obviously speaking in a minute, but we've also got a competition this evening. We've got some really nice prizes. We've got 2 JetBrains licenses for you to use. We also have 4 tickets to GoLab conference, which is happening virtually in Italy next week. So it's from the 19th to the 25th of October. Don't know if anyone's been to GoLab before, but historically it's been in Florence, and it's a fantastic conference usually over about 3 days. Great talks, great workshops, the best food of any conference I've been at probably. And they've gone virtual this year as well. So we've got 4 tickets to give away for that. So I think Alan has shared the link to, if you fill out this form, and we'll do a raffle at the end of the meetup, and some lucky people will get free ticket to GoLab or free JetBrains license.
And they do great food.
They do great food.
Definitely attend that one virtually.
Yes.
Yep.
Get your spaghetti hoops out and sit back and relax and watch GoLab. Right. So over onto the main event. You don't want to hear me waffling on all night. So they say that God loves a trier, and I say the Go word loves Matt Ryer. Yeah, you like what I did there? So Matt Ryer, engineer, podcaster, host of Go Time podcast, blogger, author. Don't know how many books you've written now, Matt? 2?
Yeah, well, they took the chapters out and put them in other books, so it's a lot more now.
Okay.
Yeah.
Fantastic. And obviously speaker, fantastic speaker, one of my favorites in the Go world, actually, if not the favorite. Matt's recently co-founded Pace, and he's here to talk about Otto, which is Pace's lightweight JSON HTTP RPC thing, as he describes it. So I will stop sharing now and give you over to Matt. And by the way, if you've got any questions while Matt's talking for Matt, just drop them in the chat, and he's happy for me to interrupt him and put your question to him. Okay. Right, Matt, over you go.
Okay. Hello, everyone. Thank you very much for having me. It's great to be here. That's the nicest introduction I've ever had, actually. So thanks for that. Yeah, I'm going to talk about this project. And I'm going to talk about this for a couple of reasons. Mainly, actually, I think the most important thing is really the thinking behind why this exists and why we went down this road. As well as some of the I'm going to dig into some of the technicalities. And in fact, we're going to use Otto to build a real thing live. You know, we're doing it virtually, so a lot of the danger's gone from doing talks and things. So to bring some of that danger back, we're just going to do live coding So stuff's for sure going to go wrong, and I'll embarrass myself and stuff, but I'm fine with that if you are. So just quickly then, we have this project management tool called Pace, and it's a rich client runs in the browser, JavaScript, and we use Svelte JS, which is a really it's kind of the same as React and Vue and Angular. It has components and you compose them in certain ways and things, but actually does all of its work at compile time. So what gets delivered is just assets that are all the runtimes kind of solved. There isn't really a runtime that runs in the browser, and so you end up with really snappy, fast, responsive UX. So that's nice. And the way it gets its data is via our API. And you can see some examples here. If I refresh this page, there's a few calls that happen in order for this to populate. And so you can see here that I've got this. I mean, sure, if you can see that, I'll make it bigger. So we have this team service get team overview here. And if we look in the console down here, we can see that it passes in this JSON payload essentially. And then you get a response, which is, again, a JSON response. And this contains all the data that you need. So it's quite standard, really, RPC, remote procedure call. It's RPC as opposed to REST because the URLs don't follow the kind of RESTful pattern, and nor do the HTTP methods. In this, everything's a post and everything has a body. In REST, you have GET requests and they're different. They can be cached usually in different ways depending on policy. And GETs will never change any state where posts and puts do. So it doesn't follow those rules. But it's still JSON and it's still HTTP. And it's those for quite good reasons, really. And they drive towards what the rationale behind why this exists in the first place. Because when we started out with this project, we didn't want to build this. We wanted to just use something like gRPC. And because of Siri, I said gRPC, not Siri. Sorry, everyone. Because of where we're running this, gRPC actually isn't an option. And there's a few other technical reasons why you have to kind of consider whether something like gRPC is going to work in your case or not. I mentioned gRPC because it's very trendy and it's very good, and they solve a lot of different problems with it. It came out of Google, and they're using it to solve their problems at their scale and in their context with all the teams that they have working, and also the progression of the APIs that they have and the backwards compatibility. There's lots of things that gRPC solves, but that comes at a cost. And the cost is that it's complicated. And we found gRPC, frankly, to just be too complicated when all we really needed was a way to just post JSON payloads around. So the other option then is to just build this bespoke in each case. But there's enough of a commonality with these different endpoints that there is an abstraction that's worth extracting, rather than solving everything again and again in every endpoint. And so that's really the thinking behind Oto and this approach. And so we open sourced it, and essentially what it is, it's a project that lets you describe your API using Go code. gRPC has protobufs, and that's a whole other syntax that you have to learn, a team has to learn. But since we just do a lot of Go, Go was a great choice for us to describe the API, and that's why we chose it. And you describe the API like this. So we have this greeter service here, and it's just a Go interface. And then there's methods. There's a greet method that takes in a request and returns a response. So we're not talking about HTTP here or anything. We're actually talking in terms of Go. And you can see that the request object is also described here and the response object. So straight away, if you're a Gopher, you already, and actually anyone probably, but especially a Gopher, can read this now and understand the API quite simply. And then in Oto, we wrote a parser which can read and understand Go code. And there's some good packages in the standard library and some coming to the standard library which help you do things like that. And it's very useful to, oh, Siri, what did I say? It's very useful to use, sorry, I'm gonna have to, how do I turn this off? Siri, can you go away? Okay, it's gone away. It said okay in my ear. Feel a bit bad now. Okay. Right, so you describe the API using Go code. We have a parser which understands Go code and essentially turns it into a set of Go types, which are kind of, it's a bit meta, but it makes sense. So you can see that we have a service type here that has a name and has methods and comments, and other metadata is extracted too. And a method has a name and an input and output object. Objects have types. So there's some complexity in this, but that's inside the parser. You don't have to worry about that. What you can do once you've got that data structure is you can then use it with a template to generate code. And this is our approach for generating the boilerplate that we need for our API. And it includes the server stub code. It also includes the Go client. This is a Go client template. It also includes a TypeScript client. And we've added recently a Swift client as well. And so the idea is that eventually we'll have templates for all the main platforms that you need to use to then interact with the API. And the other thing that we did that's slightly different with gRPC and other frameworks, they're quite opinionated because they're designed a specific way. With these templates, the approach is you copy the templates to your own project and you then own that template, and you can modify the template, or you can make changes to it to add bespoke behaviors. You can sort of do whatever you like. So you get full control. And that's different to certain other technologies. It was important for us because there were some things that we wanted and some things we didn't want, and we wanted the flexibility to be able to make that decision. Once you've then generated the code, you then use that code, you use the things that were generated to then build what you need to build. And that's what we're going to do today from scratch. And what could go wrong, essentially, is I'm just trying to be optimistic. I'm just going to start a timer so that I can make sure I don't overrun. Okay, so I'm going to make a quick, can everyone, is the screen size okay? I just want to make sure that people are all right with. I'll carry on assuming so. Okay, so to use Oto has a command. It's a command line tool which does the code gen for you, and you install it with go install, just like that. First mistake, but don't worry, I have it already installed. So I'm going to open this new folder, and I'm just going to make a server, and we're going to have a server and a client, and this should let us demonstrate the principle here. And we also have a definition folder. And remember, it's just Go code. And one of the nice things about describing your API in Go code is you get everything that you get with Go, you get for your definition. So you get type safety, you get type checks. All that tooling already exists and is already hopefully familiar. So I need an idea for a service. The classic is the greeter service. Is there anyone have any other idea for a service that we could write here? It just needs to be something that has some input and some output and a method or two. If there's any ideas, we'll go with them. If not, we'll just do a greeter.
To-do list, someone's mentioned.
Yeah, we could do that. Let's call it to don't. So to don't list is a list of things that you're not going to do. That could be our service. So it's a normal Go package here. We're going to have a to don't service, and it's an interface. And maybe we'll have add item, which is going to take a request and add item in the response. And you can see, look, I'm already getting errors here because I haven't created these yet. So I'm already starting to get help and guidance from my IDE. We'll have some text for the item. And in here, we will have, in the response, maybe we will return the item. So I'm going to also describe that. So look, as well, I can use normal Go types to describe the data. So we're going to return the item that gets created, and an item has some text and done. Well, it should be not done probably, since it's to don't. Okay, so yeah, we'll always start them off with not done, but you can see here, you can have a discussion around this design. It's actually a really nice way to describe an API with teammates, because if everyone speaks Go already, this is a nice way to talk about what you mean and what you're thinking. And I'm also going to add a comment here. So I'm going to say add item adds an item that you will never do. The to don't service, and I follow Go's comment pattern here. Manages things not to do. That becomes important later, and I'll explain that when the time's right. So that's a basic definition we have there. And of course, you can add other Go files and things, whatever makes sense, really. So we're going to have this generate file, which is going to be a script that's going to use that auto tool to actually generate the server stub for that and the client. So I'm going to start off, we have this auto HTTP, and this is the, technically you could use auto in all kinds of different ways, but the one that ships with the project is the HTTP thing that we needed. And we've already got the template for the server stub stuff. Now this uses plush templates from the Buffalo project, because actually it's a little bit easier to do some things than using Go's template. So that was the choice there. Again, we optimized for simplicity and whatever's sort of easiest to use. Okay, so this is going to be the auto server.go.plush. And I'm going to just copy it for now. Out of the box, it all works together. But of course, this is now my code for this project. So if we need different behavior, we're free to change that. You also are free not to. And then I'm going to do something like this. I'm going to say, right, using that template, the auto server go template, I'm going to write out to auto server.go. Let's run that and see what happens. So I'm just going to run the generate. I guess I should add. Oops. Okay. So if I run that little script now, you can see that it's created this auto server file. Something's gone wrong because it doesn't have anything in it. And I think that's because I didn't point it to the definition. So I have to tell it which is the source definition that we need. And there we go, it has it in there now. I'm also going to go funct this because it doesn't generate it quite perfectly. But since we have all the tooling, we don't have to worry about that because I can just go funct it. And there we go. We can see now that it's created, it's done a few things. It's created an interface for us, very similar to the interface we had in the definition, but notice it has context. The response is a pointer. So that allows you to do nil, you can return nil, and it has an error. You know, and this is nice because, you know, this is a Go server. So we want to be able to write code in the way that we write Go code. At the bottom, we have the add item request here. Look, it's created the item type also. And there's the response object, which also contains an error. And this is how errors are solved in here. Okay. Now, the only other thing I need to change is, notice it copies the package and it's just got package definition. We want this really to just be in main for now. So I'm going to change it to say package main, and then there we go, it's working. Okay, so we'll make a little main file. Normally I do this little run abstraction here, but I'm not going to do it this time just to save time. But if you're interested in that, you can Google like run abstraction in Go or something, and you'll see what I mean. All we have to do here then is create an auto HTTP server. New server. And we're going to use the normal HTTP stuff to map that server to, say, /auto. In Pace, it's mapped to /auto. So you can see that the APIs kind of lives, or the internal API at least, is all nested in one place. And that makes it very nice and easy to see what's going on. I'm going to do a log fatal and then start the server. So we'll just keep this very simple for now. Listen and serve, we'll do port 8080. It's a famous port. Okay. So there's something else I need here, because we have the auto server and we're mapping it, but we haven't given it the to don't service. And one of the things it generates is this register function here. So I'm going to call that and say, we're going to, oh, Siri, I tell you what, mate. Okay. So we're going to register this to don't service to that server, and notice it takes in a to don't service, which is that type to don't service. So another nice thing about this is I'm getting compiler errors guiding me here. So and that's always quite a nice thing. It's why TDD is a nice process, because you get help and you're sort of blocked and you have to just knock out blockers, and that's what you're doing. So, you know, if you can't think of what to do or what to don't, then it guides you. So I'm going to create a struct here for this, and that's what we're going to pass in. I'm going to just pass in an instance of that struct. Now, you could use a pointer here if you've got dependencies. This model's quite nice for if there was a database dependency, which I could imagine having in the future. You can put that as a field inside this struct, and that way, again, you get compiler help there. This is complaining now because, surprise, surprise, it doesn't have the add item method. So I'm going to go and steal that from this interface. Oh, and by the way, it brought the comment along into this interface too. It's already paying for itself. It's free. It's not free. It takes effort, doesn't it? Okay, so we're going to add that method to our to-don't service. And for now, I'm just going to return nil and not implemented error, something like this, just to make it pass. Let's see if I can run my server. I can, but it doesn't tell me anything, so it's sometimes nice, isn't it, too? This doesn't guarantee anything, but just feels better. So it's listening on port 8080 there. Okay, cool. Well, it's no good to us like this. We're going to need a client. So we're going to do a similar thing. We're going to nip over to the repo and grab that client template. And I'll create a new file in here called autoclient.go.plush. And that's the content. And you can take some time to read these templates. They're actually very readable. I think they're very obvious. And you can just see like, this is where it's describing a service. No, Siri, not now. So you can see where you're describing a service, and then for each service, we iterate here for all the services, and then for each method in the service, and then at the bottom, you have all the objects. So it's actually quite easy to write these templates too, which is a nice feature, and it's why we've already kind of the main ones for us solved. Okay, now we need to update our generate script. This is going to be almost identical. I think I can just overtype this and say client. And by the way, if you don't know that trick, in VS Code, it's Command D, and it just selects all the instances, or it selects the next instance, and then leaves them all multi-selected, so you can just overtype them at the same time. It's so cool, and it's yeah, Siri loves it. Siri loves it. Okay, let's see if I run generate, if we get our, indeed we do. And this is different, of course, because the template's different. So, you know, it's doing a different thing, which we would expect. Yep. Okay, so now we need to use our client. I'm going to make another main, package main, func main, the main entry point for all programs. This is how you know when it's package main. This is how you know you're going to be running this in a terminal, or it's going to be running somewhere rather than be imported as a package. So I'm going to make the client. And by the way, you're free to put these in different packages if you prefer. I would avoid it initially, especially if you're just writing a little tool like this. But in a bigger project, in fact, in Pace, we have the client as a standalone package. That's because we import it in multiple places. But there's no reason to do that always, you know. Okay, this takes the HTTP endpoint, which is going to be localhost 8080/API endpoint. What did I say? That's really annoying, isn't it? So we've got a client. And you think, well, where did this new come from? And it's just in that generated code. So of course, if you do have a more complicated and busy package space, you can't just have new. So you may want to put that into a different thing, or change the template. Okay, so we create this client, and this allows us to do a few things, like we can set this little debug function, which is an extremely simple way of allowing it to print out debug instructions. You can see it's just by default, it's an empty no-op essentially, but it is called, and this is how we can get some of that debug information out. If you don't like that, if you have already loggers and stuff, then it's just a case of tweaking the template to put that in, or use that logger in here even. These little hooks I find to be dead useful in Go, little functions that just do one thing for you, rather than complex types. Sometimes we can get away with it. Now we're going to create our to-don't service instance, which is the client instance that we're going to use. And I think I just new to-don't service look, and we pass in the client. So it's quite simple. And then let's have a look what this gives us. Well, we have our add item function, and this one takes the context and the request. So I'm going to just use context background for now. If you're accessing this in a HTTP environment, you're probably going to use the context from the request, and that's nice. It means it could get cancelled if the request is cancelled and you're doing some work inside this service. Or you're waiting, in the client's case, you're waiting for the server to respond. You'll cancel that operation as well. And on the server, if it's doing some work, some heavy lifting, and it has the context check for cancellation in there, it can also abort early. So it is quite nice, and it's simple enough, even if it doesn't save you too many resources. So we have to pass in an add item request, which takes some text, and I'm just going to hard code this for now, but you know, we could take it from an argument, actually. Maybe we should take it from the args. Let's do that. We'll take the first argument. So this code could panic if we don't pass in an argument, I think. And what we get back is our add item response or an error. And this is nice because, again, look, now I'm just writing Go code. If there's an error, we'll fatally log it. Otherwise, I'm going to get the text and I'm going to say that we added that item. So this is saying I didn't use it. Oh yeah, because that's inside a string. Where were you, Siri? Why didn't Siri pop up and tell me? Then it'd be good, wouldn't it? That'd be nice. One day. So the other thing about this, well, we'll get there. Okay, I'm just going to try and run this now. So we've got the server running over here. I'm going to go into the client, and I'm just using go run to run it. So let's see what happens. Yeah, I didn't pass an argument, so I need to pass in the item that we are not going to do. I'm not going to go fishing. Okay, so now we've got 404. Interesting. Didn't expect that. Let's figure out why. You can see the endpoint that it's hitting, localhost 8080, and it's passing in this JSON object. This comes from the debug stuff. The question is, oh yeah, I've used API instead of auto, so it was literally not found. Okay, now we're getting an error. Let me print here. Like, we've got a go error there. Look, so we print that out. You can see that we get this go error. So that's nice. The client understands how errors work and creates an error type, so that when you're using the service, you can just use normal errors in Go. So that's just really nice, because it's a pain when you deal with HTTP to have to worry about what's the status code, and does that mean success or not? And if not, is there an error in the body of the request? It can be quite a pain. Okay, so we should implement this. And I was thinking, in order to show this really working, we need to somehow modify this. So why don't we make this turn the text into uppercase? So it's like it screams at you because you're not doing it. That could be the rationale. This is just Go code now. So I can put these arguments on. I can use the context. I can use the request. And I'm just writing Go code. So there's something quite nice about that. I'm not dealing with JSON. I'm not dealing with HTTP or anything. That's handled for me. Screaming text can just be strings to upper. So we'll have it screaming. And then I create this response object, which I think takes an item. Yep. And I can create the item because I have that type. And the item has text, which we're going to put in as the screaming text. And then I return the response here and nil. And what we may also do is something like, oh, that's a pointer. What we may do is, if the screaming text is empty, maybe that's an error. Empty text. Okay, so I'm going to restart my server. Now we have the proper implementation of our to-don't service. And I'm going to tell it that I'm not going to go fishing. And there we go. You can see the debug, and you can see that it was added. It says it was added. And we got the data from the response. And that's it. I mean, that really is like, that's basically the crux of it. Now, we have the different templates here. So now if we had a rich client, or we had JavaScript, we have a JavaScript one too, I can generate a client for this. And you can also generate documentation. And this is something that we do in Pace. We generate our API documentation using the comments. So it's really nice because those comments are extracted, and even there's a special example tag that you can put in, and that example tag is also extracted as metadata. So you can see here, look, there's my name as an example on this field, that then allows us to create much more interesting example data here. This is generated solely from that auto data after it was parsed, because it parses those example strings, and you can see that it even understands that this type is a number, because in the example it's a number. You know, it uses JSON again as the description there. So this is actually just generated, all of this in fact, from that one Go file for our API. And there's no end to what you can do. I mean, you know, we have like just telling you the information. I find this view to be quite useful, because sometimes you just need to have a quick glance around it and see what's going on. But also we generate a CLI. We wrote our own template inside Pace that generates a command line client. So there's a Pace command, and you can see it's very familiar. That's the same service and method pairing, and you use flags to set all the values, and you get then the response as JSON, which you can then use with other tools. So it's very easy to build little integrations because of this. We also explain the HTTP, because it is an HTTP endpoint, so you don't even need a client. Obviously, we'll create as many clients as we can, but if you're writing something in C++, I'm probably not going to write a client of that. So, but you can still hit the endpoint, you can still use it. And of course, we have a Go example, which is feature complete and even has that little run abstraction. And this is very similar to the code that we wrote today. So you're welcome to use Auto if you want to. But I think the key takeaway is really about, well, it's how much we hate Siri now, isn't it? And especially because I don't know how to turn it off. The key takeaway, I think, is there's often this debate between build it or buy it. But sometimes when you know exactly what you need and you don't need that much, sometimes I think it's good to build it. You have full control. It does exactly what you need, and you're responsible for it. I mean, you know, you own the templates. So if it's not doing something you want it to do, you can go in and change it and fine tune it to what you need and what the team needs. So that's it. That's Auto. I was Matt Ryer. Siri helped me. Thank you very much.
Very nice, Matt. Thank you. We've got a couple of questions actually came in at the end there.
Okay.
If you can see the chat as well, one from Matt, that does a Go client work under WASM?
I don't know, but almost certainly if you can probably does. It depends. It uses the HTTP client. So maybe not. I don't know how that works, if I'm honest. So, but the point is, if in WASM you can make HTTP calls, then you can just write a template that does that and generate what you need. It really is trivial, and especially just take one of the existing templates and modify it. It's very easy to do. Mm-hmm. And someone says that the HTTP client normally does work under WASM. So I think then it would completely work. You can go and have a look at the Auto HTTP. It's 94 lines. It just has encode, decode. It does the server HTTP thing. It does have a not found handler that you're allowed to set so that you can control behavior there. But otherwise, it's not rocket science. And even if you didn't like Auto HTTP, you could use something different.
Mm-hmm. There's another question here from Rakesh. He says, "Hi Matt, is it not recommended to write any business logic to autoserver.go so that in the lifecycle of API, when the API spec, the request or response changes, and when we rerun auto-generate command, tool can safely overwrite the new code in OTserver.go file?"
Yeah, that's a great point. We put this at the top. This is kind of the standard thing that you should put at the top of any generated files. And actually, look, if I try and edit this, VS Code screams at me and says, this file seems to be generated, do not edit. And that's a good point. You don't want to edit this file. That's why the actual implementation interface is in a different place, because you want to be able to just, anytime you modify the definition, and by the way, maybe we add, I'm not sharing my screen anymore, am I?
No.
Let me just quickly share the screen, because that's a really good point. This is the file that was generated, and we put this do not edit comment at the top, and you get this warning if you try and edit it in VS Code. We put our implementation inside main or somewhere else, and that allows us to just run that generate as part of a normal life cycle, or usually you do it at develop time. You wouldn't do it in a continuous integration situation. But look, I just wanted to quickly just say get items. So if we added a get items here, and maybe there's some authentication to do, but we're not going to do it. And then all we're going to do is return the items as a slice of item. If I then run the generate, this file changed and was overwritten. And that's why you don't want to put anything, you don't want to change this really. Siri, and the same for the client. So yeah, good point. And I didn't mention it, but I should have.
Cool. Thank you. And then John is asking, how is identity handled in the client server request?
Well, it's a normal HTTP thing, and it has context. So you can just write normal HTTP middleware, and that's how we do it in Pace. And that basically creates the context, adds the information, the authenticated user's information to that context. And then you can then use that later in the chain. So its context is the way that that's solved. And it's HTTP, it's server HTTP, these endpoints and the server. So you can wrap that in like you would normal HTTP services.
Mm-hmm. Okay. Next question from Mark. So how would this look if Go generics come in? Does that mean AutoGen won't be as important in Go as it is now? And have you experimented with generic service implementation for Auto?
Yeah, it doesn't really help, because in a way, having the types, you probably wouldn't have as much boilerplate. But to be honest, there's nothing generic about the code actually, in a way. So you have we use the JSON package anyway, so that's already generic. I mean, it's interface. So in a way, we're not getting any type safety there, and we want the type safety. We want these methods to be spelled out so that it's clear. So probably not. It wouldn't help much in generics, but lots of other code gen situations would be helped for sure.
Mm-hmm. Okay. Next question from Tushar is, how will this handle middleware, such as for logging, etc.?
Yeah, so it's the same way. You either use normal HTTP middleware with the context. That's the recommended way. Or if there's something really specific, you can modify the server template and the client template and make your own. You could even make middleware for each, like special strongly typed middleware for each method. But it's probably easier to do it just at the HTTP level using context, because it's clearer and cleaner. But it will depend on your case. It would be quite cool to, inside the server, I'll share my screen again. Inside this template, we have for each method here, they're all the services, and these are where's the methods? Here, the methods. You could technically make a type now, which is a middleware specifically for this server and method pair, that's strongly typed, that takes in this exact signature, or actually the signature from the template. That's what you'd do. So you could even do that and have dedicated middleware types for interfaces, but I still think that's probably just a bit too unnecessarily complicated.
Mm-hmm. Okay, next question, another one from Mark. Is there an integration and unit test stubbing template? Might be handy.
Yeah, so the way that we do it in Pace is we just write code that uses the client to call the API for an integration test. That's really nice because not only are we testing our endpoints, but we're also testing the client itself. If something goes wrong in that client, it's dog fooded. So your tests will fail at that point as well. You could definitely do other things. Stubbing's quite easy because they're interfaces, so they're already abstract in a way. And if you've got dependencies between services, you could take the interfaces and just provide stub implementations, which you could then also generate. And there's a tool, I have a tool which I'll put the link to here, which actually does that. It generates, using a very similar technique actually, generates stubs for test code from interfaces in Go.
Okay, cool. Another couple of questions here. Another one from Tushar. As Auto grows in complexity, do you imagine it'll start to look more and more like gRPC?
Well, if we let it, then maybe, but it will be deliberate. It's, the point of it is that it is ultra simple compared to gRPC. And that's why, we get requests for some great ideas, but if you can solve them without adding it to Auto, then it doesn't go into Auto. And we're very strict about that because Auto just has to be the very absolute minimum that you need. The complexity comes in those templates, and you should have tests, unit tests, integration tests, protecting that to make sure that they work and continue to work as expected.
Mm-hmm. Okay. One last question from Mark. Have you got any examples of paging or filtering with Auto?
Yes, indeed. It turns out to be very simple. Let me open our Pace code. This always goes well, and I never reveal secrets doing this, so that's good. So in our definition, we have two. So we have this comments, and we have a query comments here. So you can see that we have a query type that we just describe. This takes in the ID of the org that you're searching, the kind of thing that you're asking for comments from. So it might be a card in Pace, and a card has an ID, and then a limit here. And in the response, you get this cursor type. And notice there's just one cursor type here. So that means all of any endpoints that have querying can use this cursor. And you can use the Go types. So in this case, the value will depend on the ID type. Sometimes they're numeric and sometimes they're strings. And so we've solved it in this way. If you're doing paging, you may have a type like this that asks for page, and it might have a page number and maybe a size, I don't know. What's nice about, we use a data store that's extremely fast. And one of the trade-offs is it doesn't let you do paging in that way. All you can do is make the query, and then it returns a cursor with the first set of results. You then pass that back in your next request to get the next set of results. And the way it works is it's literally an ID. It's like, I gave you up to this ID. So then we say, okay, so now give me it from that ID forwards for whatever the limit is that we specify. So these sorts of more complex business logic things, you get to just solve. You just have to solve them yourself. And again, that's nice because it's not like we've designed it in Auto and that's the only way to do it. We haven't designed it. That's for you to solve in a way that makes the most sense for your case.
Great. Okay, I think we've managed to successfully navigate all the questions there, Matt. Well done.
Brilliant.
And Siri didn't butt in there?
No.
No?
Amazing.
Fantastic.
Yeah.
Okay. Well, I will thank you very much for that. That was really, really interesting talk, actually.
Yeah, no, thanks for having me. It's lovely to be in Belfast.
It's nice to be in Belfast, yeah.
Yeah. You're
Did
in
it
North
rain?
London.
Did it rain on the way in? Yeah, fantastic.
No one's buying that fake accent, by the way, Martin.
Yeah, it's only taken me 25 years to perfect.
It's quite good.
Yeah, thanks. What I want to do, I'm just going to share my screen again now, just as we go through the last little bits and pieces. Where is it gone? Okay, so thanks again, Matt. Let me just share this. Okay, so we got our little competition. I'm sure everyone's on tenterhooks. We still got everyone who started is still with us, which is fantastic. But here are the competition winners, which have been produced by Alan, the Gopher organizer. I think he did some sort of Go routine picking these at random. So the JetBrains licenses were won by Rakesh Motakuri. Well done, Rakesh. And Nick Kobyshev. Well done, Rakesh and Nick. And the GoLab tickets went to Tiago de Franca Quieroz, to Maliki Mart, to Philip Popa, and to Ariel Piecha. Those are the 4 GoLab tickets. So well done, everyone. I'm sure Alan will be in touch.
Yeah, I've got your email addresses, so I'll ping you the details after this meetup. Fantastic.
Nice one. Just to go on a little bit, so just to mention GoLab again. So it's if you didn't happen to win a ticket, it's definitely worth having a look at this. It'll start next week from I think from Sunday. You can check out GoLab using the link there. Some fantastic talks actually, and decent workshops at GoLab, and you can virtually smell the tiramisu as well, I'm sure. And onwards, just to talk about the next meetup. So this is the first virtual meetup we've had at Belfast Gophers, and we've got some great ones lined up between now and Christmas actually. So our next one will be on the 17th of November. You can follow this link and you can sign up there, or if you're all on the meetup now, I'm sure you'll be able to do that. But we've got two great speakers lined up. I think we'll probably release the details of that pretty soon, and hopefully see you all again then. But I think that pretty much wraps it up for tonight. Thanks again to everyone for attending. It's fantastic to think that this Belfast meetup is now a truly global event. And I hope you all enjoyed the talk. And again, massive thanks to Matt for taking the time out to discuss PACE. Thank you everyone else for attending. And on behalf of Alan and Mark, the organizers, hope to see you next time. Thank you very much indeed. Okay, good night.
Thanks a lot. Brilliant, thank you. See you later.
See you later.
Thanks everyone. Bye.